students, you've probably heard it said before that hot air rises. But how do we know that's true? Maybe we read it in a book or something like that. But how do we know that hot air is rising when we can't see air? Is there a way that we can demonstrate that? Well, today I'm going to do two experiments to show something called convection, the rising of hot gases and liquids. The first thing I'm going to do is take what I call my convection snake. It's simply a spiral of paper that kind of looks like a long coiled snake. Then here I have a light bulb that's very strong. It's 200 watts, which is much stronger than the average light that you would have in your house. So when I turn it on, it of course produces a lot of light, but it also produces a lot of heat. There's some tremendous warmth right there where my hand is. I can't leave it there for too long. Let's see what happens to convection snake when I set him over the top of the light. And there he goes. He's starting to turn. What's happening is not only is there light coming out of the light bulb, as I said, but also a lot of heat. And that heat is rising. And as it rises, it hits this snake with this spiraled ramp, and it causes him to spin. Let me let out a little bit more string and see if he'll spin even faster here. You can see he's turning very slowly as that heat rises up from the light bulb. The longer I leave it there and the more heat comes out, the more he starts to spin. And I would conclude there must be something rising up against him and hitting him and causing him to turn like we see right now. So that's called convection. I'm trying this experiment here in my office at home. And the reason I'm doing that is it requires a fairly cold room. So I opened the windows on this wintry day to get it cold in here. When I did this in my classroom, the automatic thermostat kept kicking on the heater and warming up my classroom, so the experiment never worked. So teachers, if you want to duplicate this, you'll need to get your classroom kind of cold. But we're going to do a second demonstration of the concept of convection. This is a tea bag that I've cut open, removed the two ends, and emptied the tea out to form a cardboard or a paper tube. And I'm going to light it on fire, and as I do, of course, it will generate some heat as it's burning. And if the room is cold enough, we should see it launch into the air. And there it goes. That's called a convection cell. As it heated up the air above the tea bag, that air expanded. And as it expanded, it took up more room. You may see it floating down now as it cools off. As it heated up the air expanded, causing it to be less dense, and that column of air floated. And as it floated, it vacuumed up the ash of that tea bag. Once it got up in the air and cooled off, the air became more dense and the tea bag floated back down. That's called a convection cell. So we can demonstrate the fact that the air, the hot air, is moving, it is rising because it sucks up that tea bag. So teachers, you can try that experiment yourself in your classroom. Just be careful, of course, as you're burning this paper. Have a fire extinguisher handy. So what causes convection? Well, you might remember in one of my videos on temperature that the warmer things become, the faster their molecules move. And the faster they move, the more they push other molecules away. And this is called expansion. When things get hot, they expand. As, for example, your thermometer. On a hot day, the mercury in the thermometer expands up the tube. On a cold day, it does the opposite as those molecules slow down. It contracts. So the air in this room is composed of molecules of oxygen and nitrogen. As this light bulb heats up those molecules, they move faster and faster, and they start to expand and move farther apart. So there's fewer molecules here than there are over here, where they're colder and more condensed. So as those molecules start to spread apart, they start to weigh less. And as they weigh less, they float. Just like something that doesn't weigh much in water will float, and something that's heavy in water will sink. Well, air behaves the same as water. When it gets light, as when those molecules move further apart, they expand and that air floats up. If I were to stand on this table, up there near the ceiling, it's much warmer than it is down here. The air is much warmer because all the light air that is hot has floated up to the ceiling. Maybe you've been swimming sometime in a lake where you dive way down and you notice the water gets colder as you go down because the warmer water has floated to the surface. I sometimes compare it to a school dance. When the music is slow, the dancers are close together. But when the music is fast, they move further apart. And molecules kind of do the same thing. When they move slowly, they contract. They move closer together. And when they heat up, they move faster, and they're kind of like fast dancers. They have to move further apart. So that's what causes this convection of air, this idea that hot air rises, or even hot liquids rise. That's called convection. Convection explains why a hot air balloon can fly up in the air. Let's look at an animation. Here we have air composed of many molecules. Once the molecules of air inside the balloon are heated by the pilot, they move faster and expand. In doing so, they take up more space and become less dense. That means that the air inside the hot air balloon weighs less than the colder air outside of it, and therefore it floats because it weighs less. Just like anything in water that doesn't weigh as much as the water will float. So as those molecules move apart and expand and take up more area, we have less density, and that hot air balloon then floats on the colder air molecules that are around it.